This video is about how to configure a SensoPart VISOR smart camera to talk over Ethernet IP. While it's specific to Allen-Bradley control logics and compact logics, much of it applies to any PLC. Here's an outline of what we're going to cover in the next 12 minutes. Connect all the visors and the PLC to an Ethernet switch, just like any other Ethernet device. Make sure there's no duplicate IP addresses. The configuration software is in the SensoPart folder, and it's called VISOR Vision Sensor. All visors found on the network are shown in the top window. If not, click on the Find button in the lower left corner. This shows the default visor IP address. Double-click on the desired camera to configure it. Here's some settings to help get a good image, but making that happen is another set of videos. We're going to read an ECC 200 code, so select the 2D matrix tool. To select Ethernet IP, click the Output Setup button, then click the Interfaces tab at the bottom. Here you configure the payload with all the data you want to send to the PLC. To add a new item, click the plus button. Later when we test communications, we'll look to see that the code read is demo 4 and that the execution time is 91. Install the electronic datasheet EDS file for the visor. In RSLogix 5000, click EDS installation from the tool pull-down menu. The EDS file is installed with the SensoPart software. This shows the default directory. You also get two add-on instructions, one to change jobs and the other to trigger the camera. When you do trigger the camera, the visor applies with the data you configured in the payload earlier. Install 2 visors on the EtherNet network in your project. Here we're adding the second visor just to show that you can have multiple visors on one network with one PLC. Insert the AOI into the project and include the job change even if you only anticipate one job, because it's easy now and it's a little more difficult for another person to go add it after the fact later. While we're repeating steps on adding the second AOI, I just want to mention we also have a macro that'll convert the payload information from the visor into a comment file that can be directly imported into RSLogix. So this means however you configure your payload, you're only a few steps away from having aliases mapped to the addresses read by the triggered AOI. Check it out. Add the AOIs into a ladder routine. Add a rung to trigger the camera. This tag, ETH2, ETH2, is a one-dimensional array where all the data shows up after you trigger the camera. And we'll need to know the name of this exactly to import comments into RSLogix later. Use the exact tag in both input and output areas of both AOIs. Set this communications timer conservatively. When the sensor times out, the part's declared bad. And there's also a timer inside the camera, and you can't have the camera take multiple pictures for each trigger. Create a new tag to trigger the camera and link it in the output coil to a tag name defined in the trigger add-on instruction above. So just download the project in the normal way, probably using whoactive. But if you've configured it before, then you can do it from the communications pull-down menu. To trigger the camera, select the contact and toggle that bit by pressing Ctrl-T. On the rising edge, the camera will trigger. After a successful job change with no errors, the visor is ready to run the new job. On the rising edge of the next trigger, it'll run the newly selected job. Obviously, you'll want to add a tag name for the job number. Next, we're going to test communications by looking at the camera configuration software to see what some values are and monitoring the input buffer in the PLC to verify those same values got transferred across. As a side note, for strings, you'll need to set the maximum length in the detector and set the minimum length to the same value in the payload. The VISOR software shows an execution time of 47 milliseconds. And the value of the input buffer in the PLC at position 52 is also 47. And it's 47 because this is an integer, but real numbers actually get sent over to the PLC as integers with an implied decimal point. So for those, you have to divide by 1,000 in the PLC to get the actual value. This is just describing a little bit about how the VISOR payload data is mapped into the PLC. Next, we'll test that the 2D code was read successfully. So you'll be able to see in the PLC the bit goes high when it's read successfully. And in another area, you can see the actual string, the ASCII string that was read by the VISOR. You can see the string from the 2D code in the payload. Earlier in the results, we saw that this was demo 4. And here in the PLC, you can see demo 4 after you switch the radix to ASCII. Again, it's best to set the length of strings in the detector and in the payload. This will especially help later when converting VISOR payload information into RS Logix tag names. All integers get mapped into this area starting at element 244. This includes integer, single, and double integer tags, and floating point from the VISOR, which are, again, integers with the implied decimal point at 3 places. That's the EtherNet IP introduction. Check back for more videos.